monitoring, presented by Marlon Agüero. Marlon Agüero is a graduate student on the Department of Civil Construction and Environmental Engineering. And he has a very interesting presentation in a very innovative topic of augmented reality. I hope you enjoy his slides, and also I hope you ask him anything you want to know about augmented reality. He'll be very glad to explain this technology to you. Marlon, are you ready?
I'm ready.
Thank you. I'll mute my phone. Thank you so much.
Okay. Good morning, everyone. This presentation is on the application of augmented reality in cost-effective wireless structural monitoring. Basically, I will be talking about how to help inspectors get better access to data they receive from sensors by using an augmented reality device. Here is the plan of the talk. First, I will present a motivation for this presentation, and I will explain why I am working on this topic. Then I will explain the notion of augmented reality, which is a tool that we use in this project. Then I will talk about wireless sensors that we have applied, and I will also discuss how the working of the sensors can be improved by the application of augmented reality tools. Finally, I will outline the perspective for future work and present the conclusions. It is very important to take good care of engineering infrastructure, such as roads, dams, airports, and bridges. This photograph shows what happened in a bridge in Templeton Lake in Arizona. This event happened in July this year. There were no victims, but the collapse and train derailment resulted in fire and chemical leak. The bridge was old. It was built in 1912. Most likely, the bridge wasn't maintained properly. American Society of Civil Engineers regularly publish an infrastructure report card, which scores for different types of infrastructure. The scores looks rather bad for most types of infrastructure in the United States. For example, bridges get the score of C. What is also very important is that the cost of improvement the infrastructure is becoming higher and higher due that reason. To prevent such bridge collapse and other diseases from happening, we need to apply structural monitoring procedures. For example, we need to examine displacements. This will lead to both increased safety and performance of the infrastructure. Wireless sensors versus inspectors on the field. So the basic question in this talk is how to improve structural monitoring procedures. I will argue that this can be done by helping inspectors get better access to the data they receive from wireless sensors mounted on infrastructure. Right now, we don't see a good connection between the sensors and the infrastructure on the field. I will also show what technology we can use to achieve a connection between the data coming from the sensors and inspectors. What technology can we use to achieve this? I will argue that we can do this by the application of augmented reality devices, such as the headset called HoloLens from Microsoft presented on the slide. This device has multiple cameras to sense the real world, and also it has a visor to display information onto the visual field. We can improve the inspector's performance with this device. Normally, inspectors go to the field without an augmented reality headset, and they can only rely on their own vision to register data. As a result, they can miss some important data and observations. As a tool to help them, we want to develop an application that they can use on the field so that they can visualize a bridge and get more knowledge about the bridge and what is happening to its structure. In this way, they will also have access to more data, which will allow them to make more informed decisions. Let's first briefly explain the notion of augmented reality and show why it is very useful for all purposes. What is augmented reality? Augmented reality combines virtual elements, which we call augmented, with the physical environment that exists in the real world and are part of the reality. The physical environment could be all elements that are around us. For example, the chair, the table, the window, and so on. When we combine the virtual elements with the physical environment, we get an augmented reality experience. Here we have an example of an AR tool. We have developed an application to measure the length of cracks in the structure. We simulate an artificial crack on the wall, and then with the HoloLens, we can use our fingers to determine the length of the crack. We don't need to use a tape or climb a chair to measure the crack on the wall. Now let's talk about wireless sensors. Please take a look at the components of wireless sensors. A wireless sensor has a sensor that could be a strain gauge, an accelerometer, or any other kind of sensor. The sensor has to be connected to a microcontroller, which is like the brain of the sensor. It helps to process all the information coming from the sensor and perform calculations. It is like the computer of the sensor. Also, we need a component to send the data received from the sensor wirelessly. For example, to a computer. In this case, we use antennas that connect the sensor platform with any other device, such as a computer, a phone, or the HoloLens. The sensor needs to be powered with energy, so we use a battery. Let's now see how the experiment was set up to test our sensor in our laboratory. In this experiment, we simulate a bridge pile. As an instrumentation to measure displacement, we use our wireless sensor that we call Lewis 2. And at the same time, we connect the LVDT to obtain displacements of the pile and to compare the two displacements. This setup simulates a real pile, but in this case, the pile is inverted, as you can see in the picture. The shade table represents the slab of the bridge. We apply in the shade table different train displacements to simulate the train crossing over the bridge. We apply 5 different train displacements. We measure the displacements on the pile with the wireless sensors and the LVDT. And here we have our results. In our results, in the orange lines, we can visualize the wireless sensor displacement calculation, and the blue line is the reference displacement obtained from the LVDT. From the 5 trains, we can see that mostly of them had similar results. We estimated the errors from our calculations with these 2 formulas. The first one used the maximum peak displacement, and the second one, the root mean square. And we obtained that our errors with our wireless sensor was less than 11% in comparison with the LVDT. What is the connection between augmented reality and sensors? Basically, we apply augmented reality to improve access to the data we get from sensors. Let's see how to do that. To connect the 2 components, we use physical elements, which in this case are sensors. We send the sensor data to the server. The server is connected to the internet. The server can send data to an AR device, in our case, the HoloLens. When we have access from the HoloLens to the data that is in the server, we have an augmented reality tool that helps us to see what is happening to the structure. For example, when we have a sensor that is an accelerator, we can visualize the acceleration of the structure at that moment in real time. Here we have how was our hardware and software setup. For the sensors, we use Arduino-based sensors, and we program our sensors with Arduino I platform. The server in our experiment consisted in a computer surface, and the server has as a software a socket to receive the data from the sensor that is called Node.js, and also it has installed a database that in this case is MySQL, that is an online database. In our AR headset, we use Microsoft HoloLens, and to deploy our applications in our HoloLens, we use Unity and Visual Studio. With all of that, we obtain an augmented reality tool. Here we have an example how we visualize the data coming from the sensors in real time. We see that we are moving the sensor with our hand, and we are visualizing the data coming from the sensor into the HoloLens. What can be done in the future? How can we improve the working of sensors through the application of augmented reality? For example, we can use a 3D graph as a hologram showing displacements of a real bridge. Then we can combine information from different sensors to have a better assessment of the bridge. Like, for example, we can use accelerometers, strain gauges, etc. So to conclude this presentation has introduced a new wireless sensor platform which collects data using a low-cost sensor to measure displacements. Moreover, in the video showing the presentation, the platform allows real-time visualization of the data in HoloLens. Thank you for your attention.
Thank you, Marlon. Very nice presentation, and I think it's a very good topic, very good summary of the work that you combine the low-cost sensor with augmented reality. That in fact is different Tran-SET projects that we've been doing from the beginning of the center, year 1 and year 2, and now year 4 we're doing also augmented reality with the NMDOT. Very interesting area. We have time here for questions. Let me see if anyone has any question. Please go ahead and ask. I will start with questions. I think we have some time here. Marlon, in your opinion, because you have industry experience, you have programming hardware experience, you have knowledge about the industry and the hardcore research, in terms of departments of transportation, there is a resistance to actually use augmented reality because it could be too intimidating today. I know it's not going to happen in one day, but what would be your comments about how could this eventually be not such as an intimidating technology and more friendly? What are your thoughts on this?
Thank you for your question. I think that is a challenge for all new technology. And I think that a good way to start using a new technology is just using that. Bringing the inspectors the tool so they can start using that. And when they see the results of what they are doing with that technology, they will become more interested on that, I think. So the best way is to start using the technology if we want to implement that on the field.
Great, and you didn't mention here that you kind of did that. We had this workshop with the NMDOT. What was your, I mean, we don't have time to talk about that on your slides, but you already talked with them and you received some positive feedback from them. Can you summarize for the audience what were their initial comments or their suggestions in your technology?
The comments from the inspectors were that when they go to the field, they don't have all the data available on the field because they have multiple databases that they go to some specific people that analyze that data. But when they want to take decisions on the field, it's very hard for them to access that data. So if this kind of technology can help them to have that data easily to access on the field, I think that it could be a good tool for them. They were very interested when we showed them some applications that we are developing with AR. They show a lot of interest and told us some ideas to continue working on this topic.
Thank you. Yes, I think the connection with industry and stakeholders is obvious because they are even providing us their feedback and support for exploring this direction. So it's very promising. Dr. Ali, go ahead and ask Marlon. Don't ask him very hard questions. Go ahead.
Thank you. Well, not specifically to Marlon, but also to you maybe. When I look at the structure and when the structure shows me the time domain vibrations, so I'm not sure if that data makes sense to me. So I guess what I'm trying to convey to is how human accessible the parameters needs to be so that we can make sense out of it. Because the idea is, I understand that you are showing some metrics, but I don't have personally the ability to extract information just by looking at the time domain data. So I guess my question is, why, for future, what are you planning to do?
That's a good question. Yeah, it's something that I also discussed with my advisor about that. So our goal is to not only visualize data, also to visualize what is happening with the structure in a 3D visualization. For example, we have a bridge and we can overlap over that bridge a hologram that shows us with colors what is happening with the bridge. For example, where are the highest displacement. So seeing that data as a 3D graph, it will help or will inform more data about the structural properties of the bridge that only displaying the data that could be very confusing for the people that is what visualizing it. So it could be an improvement to make holograms with that data that give us more information about the structure.
That's an excellent question and an excellent answer to continue with the session. Thank you for your participation, and thank you, Marlon, for an excellent presentation. If you have any questions, feel free to send them private chats or ask the information. You have the email of Marlon and continue the conversation. We'll continue with the program with the third